This video is going to take you through the properties of the rose curve that you looked at in the polar investigation, and also how to graph by hand without your calculator. First thing that you noticed in your investigation, that A was your petal length. So your equation is R equals A sine n theta, or R equals A cosine n theta. So A is going to be your petal length, that's your first number. And then the n varies. So if you have an odd n, it's going to be the number of petals is that number. If you have an even n, it doubles the number of petals. And that has to do with the cycles of the graph and kind of where those fall on the rectangular side. When you have your degrees between your petals, or radians, I'm going to do both here. If it's odd, you're going to have 360 divided by n. So it's always going to be 360 divided by your number of petals. And then if it's even, it'll be 360 divided by 2n. That'll give you your degree measure between. And then you can do the same thing for radians. 2 pi divided by n, or 2 pi divided by 2n. I think that's the way to look at it. Really just divide by the number of petals. Since it's easier on our polar grids to use radians, you're probably actually more likely going to be using that value. Okay, now the key here is going to be coming up with the petal that you're starting at. So you notice with the sine and cosine ones, they're rotated slightly differently. Same reason that they were horizontally shifted on the rectangular plane. So take a look at our first example for sine 2 theta. We have our petal length is 4. It's even, so the number of petals is actually going to be 2 times the n value. It's going to also be 4. And the radians between your petals, or degrees between your petals, we'll do radians since, again, this is an easier thing to do with radians. We're going to do 2 pi divided by your number of petals, which is going to give us pi over 2. Should be fairly easy to count later on. Now to find your starting petal. And we're going to be looking at the maximum points here, or the end points of the petals. So the maximum length of the petal is 4. Maximum distance out. So we're actually going to take our equation and set it equal to 4. So we're going to set it equal to the petal length. What you'll notice will happen every single time we do this is we can divide that out and get 1 is equal to 1 sine of 2 theta. Now you probably thought we were finished with this, but we are going to solve this sine inverse equation, and we'll get 2 theta is equal to, so inverse sine is pi over 2. Now we're just looking for the starting petal, so we don't actually have to worry about all the values of theta that are possible, because we're going to use that distance between to figure that out. If we divide by 2, we're going to get theta is equal to pi over 4. So the key here is getting that starting petal. So we're going to start at r is 4, and theta is pi over 4. And then the distance between is going to be 6 pi over 12, which will make it easier to count. So pi over 2, but let's make it 6 pi over 12. So we're going to start at circle 4 and pi over 4 here. And if you count 6 pi over 12, we'll get all the endpoints of our petals. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And we'll always have one also in the center. So we're just going to sketch this out. Probably not going to do an amazing job on here. I'll do my best. kind of did a little overlapping here that shouldn't be here. I'm going to fix that a little bit. You should be connecting it with the center. Yeah, it's a little bit better. I'm not really concerned about the distance the petals are going out. I'm concerned about those maximum points. So we're also going to label those right on the graph. We have 4 pi over 4. Make sure these are simplified. 4, 3 pi over 4. 4, 5 pi over 4. And then 4, 7 pi over 4. These look a lot prettier on the Desmos, but do your best to draw them in. So we're going to look at one more. You can pause this for a second, make sure you get all the information on here that you need. We'll look at a cosine and an odd one as our next example. Okay, here, similar stuff. We got our length is 5. The number of petals is going to be an odd, so it's going to be 3, for n is 3 here. Since it's odd, it's going to be the exact number of petals. And the radians between will be 2 pi over 3. We might as well make that into 8 pi over 12 right away to make it easier to count our distance later. Again, to find our starting petal, we're going to set it equal to that maximum, so 5, or the petal length, equals 5 cosine 3 theta. This one's a little easier, cosine, because if you get 3 theta, inverse cosine of 1 is just 0. So we're going to get theta is equal to 0 as our starting petal. You'll notice the cosine ones are always a little easier because they do start on 0 every single time. So we'll start at 5, 0, and then we're going to count that distance of 8 pi over 12 between each. 1, 2, 3, 4, 5. And then we're going to count 8. 1, 2, 3, 4, 5, 6, 7, 8 is our next one. And then 1, 2, 3, 4, 5, 6, 7, 8. And what you'll notice too, if you count the 8 out again, that'll kind of help you make sure that you got it in the right spot. This one came out a little better as I'm getting practice with this on the tablet. So again, we're going to label our points 5, 0. This one would be 5, 2 pi over 3. We already knew that was our distance between. And then 5, 4 pi over 3 would be the next one. So again, to recap, graphing with the rose curves. The key is knowing how many petals that you're going to have, setting your equation equal to the petal length, and solving that for your starting petal. Make sure to label the petal endpoints. Those are your critical points.